Hi everyone, today we'll do a question from ray optics. This question has appeared in one of the JEE advanced exams. Okay, so the question says that there is a glass beaker which has a solid plano-convex base. Okay, so you have to think that this is the glass beaker whose base is plano-convex. Okay, so this is glass. Okay, and some liquid is filled up to the level QPR. This is a liquid, okay, liquid. And refractive index of that liquid is unknown. It is given as N. And refractive index of this portion of the glass is given as 1.6. The lower part of this, the plane surface part of this base has been silvered. So this will act like a plane mirror. This will act like a plane mirror. Okay. An object is kept at a distance of h. This height is given as h from the bottom of the beaker. So from O to T, this height is given as h. And the radius of curvature of this curved surface is given as 9 centimeter. Okay. Now the question says that the image formed by this system for this object lies on the object itself. So the image of object O is formed on itself. So image is formed here itself. We have to check which options are correct. Basically, we have to find relation between refractive index of this glass and the distance of the object from the bottom, this height. So once we know the relation between these two, we will substitute one of them and check the value of the other one. And then we will decide which options are correct, isn't it? Now the main thing here is the image of this object should be formed on itself. Now how is that possible? Well, that is possible if while light traveling through this liquid and through this glass, it should hit this mirror perpendicularly. Why? Because if it hits the mirror perpendicularly, then it will go back. According to which principle? Reversibility principle. Suppose light comes this way and after passing through this media, let's say it bends like this. And here if I have a plane mirror, then it is hitting at 90 degree. Then light will reflect and go back like this. Okay. For example, let's say this is some surface of some medium and light bends, let's say this way. Now if you put a mirror here perpendicularly, light will come this way. That means if I consider these two systems, this liquid lens, this is the liquid lens and this is the glass lens, then since light from this object after passing through this system should come this way, after passing through this liquid and through this glass, since light should come this way after passing through this. Now what does this mean? It means that this system can be thought as a convex lens whose focus is where this object is. Why? Because if an object is at the focus of a convex lens, then after refraction it comes parallel to principal axis, isn't it? So what this means is the equivalent lens of these two lenses will be a convex lens whose focus should be wherever is this object. Therefore, the focal length is same as this height h if you neglect the thickness. In any way, in this question, the thickness is not mentioned, so we will assume it to be negligible. So this h can be measured from either here or here. That doesn't matter because this thickness is negligible. So this h is the equivalent focal length of this liquid lens, which is like this, and this plano-convex lens, this is like plano-concave, and the lower part is like plano-convex lens, right? And you can see these two are in contact, and we already know the formula for equivalent focal length for two lenses in contact, right? So let's say focal length of this is f1, focal length of this is f2. So what should be f1? Well, lens maker formula we will use. 1 by f1 is equals to n minus 1, 1 by r1 minus 1 by r2. Actually, we write n2 by n1, but here surrounding medium is air. So I will write n, where n is refractive index of the lens. Here the lens refractive index is n. Okay. So this refractive index is n, which is not mentioned. So 1 by f1 will be n minus 1. Let us say light is going this way. So this will be first surface, right? So for first surface, the plane surface, the radius is infinity. Plane surface has infinite radius. Minus, and this curved surface will have radius this way. I hope this part you understood. This curved surface, if I show you here, will have center this side. So radius will be this way. From pole we have to measure, or optic center. So since radius is this side, which is same as incident ray, it has to be taken positive, remember. So this R2 radius was given 9 in centimeter, and 1 by infinity is 0. So what will be 1 by f1? So from here 1 by f1 will be n minus 1 by 9 with a minus sign. That minus sign is nice to see because this is a concave lens, plano-concave lens. So its focal length should be negative according to our convention, right? What about this plano-convex lens? 1 by f2, that will be n minus 1, 1 by r1 minus 1 by r2. Surrounding medium is air, so only I will write n2. n1 is surrounding medium's refractive index, which is, we are assuming, 1. Now what is refractive index of this medium? This is this glass, which is 1.6. So 1 by f2 will be 1.6 minus 1. This is 0.6. And radius of light is coming this way, so this will be your first surface, right? And for first surface, wherever light hits first, that surface is considered as first surface. So R1 is radius of that surface. So for this surface, radius is in the same direction as incident ray, so positive. And this is plane surface, so infinity. So 1 by f2 is equals to 0.6 by 9. Right? This is 1 by f2, this is 1 by f1. Now already I proved to you that the equivalent focal length of these two liquid and glass lens together should be like a convex lens whose focal length equivalent is same as this h. This is capital F, okay, equivalent focal length. So 1 by equivalent focal length is 1 by f1 plus 1 by f2 for two lenses in contact. What should be equivalent focal length of these two systems? H. And I hope you understood why. Because light has to retrace. So this light that comes out must come this way, perpendicular to the mirror here. Then after reflection, it will go back like this. Then image will be formed at the object itself. So what is 1 by f1? Minus n minus 1 by 9 plus what is 1 by f2? 0.6 by 9. So 1 by h will be 9 if I take LCM minus n plus 1 plus 0.6. So 1 by h will be 1, this will be 1.6 minus n by 9, isn't it? So what will be h? 9 divided by 1.6 minus 9. Now let me check whether the first option satisfies this equation or not. The remaining three options, I request you to please try yourself. Okay. So n is 1.42. So what will be h? 1.6 minus 1.42. That will be 8. 5 minus 1, 4 points. So 0.18. That is 900 by 18. 9 2s are 18. 250s are 100. So this is satisfying, right? So option A is correct. Now let us try to do the same problem using single surface formula. So you can see first the light will pass through this surface, right? So if I draw that surface here like this, then this side refractive index is n, and here there is nothing is mentioned, so we will assume A. So this light is going from here to here. So this is where there is incident ray, this is where there is refracted ray. Now for single surface formula, we have N2 by V minus N1 by U equals N2 minus N1 by R, isn't it? Now let me assume that the thickness of this is T. Of course, we have to take later that this thickness is negligible. But let's say in another problem, this thickness is given to be few centimeters. Then how to do? So let's say this thickness is T. Now, when I apply single surface formula for this surface, we have to measure the distances from this surface. So remember, object is here, O. So this U is your object distance this way. Light is coming this way, but you are going this way, so object distance will be negative. How much? Minus, this will be object distance. So from here to here is h, this is t. So it will be h minus t. In this problem, you can take it h itself because this t is obviously negligible. But I'm just wondering how the answer will come if this is t. Okay. So what is N2 now? N2 is where there is refracted ray. So refracted ray is in liquid, so this will be N. V is image distance from this surface which we don't know. N1 is the refractive index of the medium where there is incident ray. This is where there is incident ray. And now incident ray is in air, so this will be 1. Object distance is opposite to incident ray. So minus h minus t. And since this is flat surface, radius will be infinity. And whatever is this, we know that something divided by infinity here will be 0. So this thing is 0. So n by v minus minus plus 1 by h minus t will be 0. So n by v will be minus 1 by h minus t. So v will be what? Cross multiply minus n h minus t. Okay. What does minus sign mean? It means that the image will be this side, right? Opposite to incident ray. So let's say this is the first image created by refraction through the plane surface of the liquid. So this is the first image whose distance from this is this V. Okay. This is V. Now for the second surface, for this surface, this image will now act like what? Object. That is how we do problems in ray optics when there is multiple refractions, right? So the image made by first refraction will be object for the second refraction. Now we'll consider refraction through the second surface. Okay. So this is the liquid glass surface, and this red one was air liquid surface. Air liquid. So here remember the refractive index here is n. Here it is 1.6. And now I1 will act like object, and this is the pole which is same as this surface, right? This surface is here, right? So this distance will be now object distance for this surface, which was V, right? This V. So now this V will be object distance for this surface. So let us use now again our single surface formula. N2 by V minus N1 by U equals N2 minus N1 by R. Now N2 is where there is refracted ray. Refracted ray is in this medium, which is having refractive index 1.6, right? This medium. V is the image distance, V dash, let me write. N1 is where there is incident ray. Incident ray is in this liquid this time. So N. U is the object distance. It is opposite. This will be your object now, right? I1. Whose distance from here, this line, which means from the pole of this surface, is the distance is this, right? Distance is this. Minus sign is there to tell it is opposite to incident ray. So distance is this. So what will be your object distance? Well, it is opposite to incident ray, so it will be minus. And distance is how much? N H minus T. Okay? Is equals to N2 is 1.6, N1 is N divided by radius of this will be down here, so it is in the direction of incident ray, so positive. So minus minus will make this 1.6 by V dash plus N will cancel 1 by H minus T, 1.6 minus N by 9. Now we know that the light that after crossing this surface, the light that comes must come this way, right? Then only it will go back. Therefore, if this mirror was not there, where will the image be formed? You can check. Same thing will happen for this light. So if this mirror was not there, where will the image be formed? Infinity, after refraction through the second surface. That means this image distance will be infinity as per the question. So therefore this part will be 0. So you will get 1 by H minus T is equals to 1.6 minus N by 9. So here you can see 3 variables, right? So that's why we need to assume this thickness is negligible compared to this height. Then this T will go, and then if you take reciprocal, you will get H equals to N by 1.6 minus 9, which was the same formula which we got before, right? Now, if you have a lens whose one side is silvered, then we know that this whole thing will act like a concave mirror whose equivalent focal length is, let's say, capital F. And this lens, this can be divided into lens and mirror, isn't it? So this lens individually has focal length FL, let's say, and this surface, which is like a mirror, has focal length Fn. Then this whole thing will act like a mirror whose focal length is capital F. Now how these three are related? 1 by capital F is equals to 1 by focal length of this mirror minus 2 by Fl, where Fl is the focal length of the lens. How this 2 comes, you can think of that as light is first refracting through the lens, then reflecting from the mirror, then again refracting through the lens. So lens contributes 2 times in refraction. So that's why you can think this 2 is coming. Okay. So remember, this F is the focal length of this combined system which acts like a mirror. Also remember that in this formula we have to put sign while putting the given values. Now, in our question, we had this plano-convex lens, the glass whose refractive index was 1.6, and the top part we had some liquid, isn't it? And here this part was silvered. So this is very similar to this kind of system, right? Lens whose one side is silvered. So I was thinking, why can't we use this formula and try to solve the same question? So for that, what I will do, First, I will convert this system into single lens and mirror, plane mirror. So these two, the glass and the liquid, the equivalent of those two, let me call as FL. Okay, equivalent. This is equivalent of the liquid lens plus the glass lens. So these two. And then this side is silvered, which is plane mirror. So this is a plane mirror. So focal length of this is, let's say, FM. But for plane mirror, we know focal length is R by 2. And for plane mirror, radius is infinity. So focal length will be infinity. So that we know already. So once I do that, once I convert this into this is something like this, right? So we can use this formula to find the effective focal length of this whole system, including the mirror. Now, what is the equivalent focal length of the liquid lens and the glass lens? That we already did. 1 by FL will be 1 by F1 plus 1 by F2. F1 is focal length of this liquid part and F2 is the focal length of this glass part. In our previous method, we used here capital F, right? So now I am writing that as Fn. Now we already saw that 1 by F1 was equals to minus n minus 1 by 9 and 1 by F2 was minus, not minus, plus 0.6 by 9. So I hope this part you remember. Okay, you can check the that part once. So 1 by FL will be equals to, this is minus n minus 1 by 9 plus 0.6 by 9. So 1 by FL we found. So this 1 by FL we found. Now Fm we know is infinity in this case. So 1 by infinity is 0. So 1 by F of this whole system, including the mirror, remember, will be equal to minus 2 by Fl. Right? Okay. Now in our original question, this was our glass lens and this was our liquid lens. And this side was silvered. An object here, the light from that object went in such a way that after refraction, it hits the mirror normally. Then it will go back this way. So you can think of this as a concave mirror where light hits this way and goes back this way. So this whole system is acting like a concave mirror, right, which will form the image at the object itself. Now when does concave mirror form object at the image? When it is at a distance of twice of focal length, isn't it? So this distance should be twice of f, which was given to be h in our question. Distance wise, this is h. So what will be f distance wise? H by 2. Now while substituting here this f, we have to put which sign, and we know that this system is acting like a concave mirror. So f will be minus h by 2 is equals to minus 2 by f. So this 2 will go up and that 2 and this 2 will cancel, minus and minus will cancel. So FL will be H. And that means this FL will be H. And I think you remember, right? From here on, we will get the same answer as we got previously. So if you want to think this way, you can do that. So the more variety of ways you think, it opens up your thinking capacity, which is always good to solve entrance level questions, right?